Hello everyone, welcome back to the Computer Networks lecture. Right now we are going to continue our discussion on the wireless, chapter 7, wireless and mobile networks. We're going to talk about the cellular networks, 4G and 5G especially. Actually in this latest edition, 8th edition, the discussion on this subsection is just 4G and 5G, but then I think it is a good idea also to show the evolution of the cellular network from 2G up to 4G. So I'm adding those materials also here in this video. Okay, so let's start with the 2G architecture. In general, this is not only 2G, but then it can also be applied to the other generation. But in principle, there are this kind of architecture. First, we have cell. The cell is like the BSS in the Wi-Fi networks, where it consists of a base station or access point in the Wi-Fi networks, and then there's one base station in one cell, and there are several mobile users or mobile terminals, okay, which are attached to the base station, and then there's our interface or a wireless link between the mobile users and the base stations. Okay. And now there's another entity called the MSC. If you are using the Wi-Fi access point, Wi-Fi networks, then let's say we have a router, okay, that connects or bridge between the Wi-Fi network and the wired networks. So the same in here, we have the MSC, which is the gateway or the bridge between the cellular network and the wired telephone networks. And also, it's not only between the cellular network and the wired telephone networks, but also between different cellular operators, like, I don't know, maybe Indonesia, Telkomsel, and Indosat, Telkomsel, and XL, and so on and so forth. All right, and then there's another function of MSC, which is to manage call setup. This is taken from the old slides, which we are not going to discuss later. But then, if you recall, in the first chapter, we talk about the difference between the circuit switching and the packet switching. So in the early era of cellular networks, 2G and 3G, especially the voice traffic, it was still based on the circuit switching. Okay, so before the two parties can communicate, they have to set up the call. Okay, and this is done by the MSC. Also, mobility. So basically, mobility is very important function or very important features in the cellular networks. No matter if it is in 2G, 3G, and 4G, even 5G, the mobility has to be there. But then, especially for 2G and 3G, this mobility is handled by MSC, and in the 4G, it uses different entities, which will be explained later on. Okay, now let's have a look at the first half of the cellular networks, especially in 2G. Okay, so there are two types or two techniques to share, multiple users, mobile users within one cell. So the first one is the combined FDMA and TDMA, which is utilized or used by GSM networks, and the other one is CDMA. Okay, so for CDMA we have explained in the some videos before. I'm just going to talk about the FDM, combined FDMA and TDMA. So this picture have been I'm reusing this picture when we talk about the interference. Okay. So remember, if we are using the same frequency in adjacent cells, then there will be intercell interference. Okay, so we don't want to have that intercell interference. So what we can do is that we assign different frequency in different cells. So basically, this FDMA is done for base stations in different cells, in adjacent cells. So that there is no intercell interference. And the same frequency can be again reused after two cells away or one or two cells away. So for example, like this, frequency number 2 is used again in this in the cell. Okay, after one or two cells away. Frequency 1 is used again here, 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 here. Yeah, that's it. And then within one cell, so basically the base station is using the same frequency band. Okay, so let's say it is using frequency number 1, or let's say this is number 1, 2, 3, 4, 5, which is used in different cell. Okay, and then to manage the communication between the base station and mobile users, multiple users, different mobile users are using different time slot, okay, to communicate with the base station. So this is to to avoid collisions, right? So unlike what we talk in the random access techniques, all the mobile users can communicate anytime, and using the same frequency. So here there is this time slot is already managed by the base station. So base station tells all the users, okay, when they can send the data. So for example, user 1 can only send the data at time slot 1. User 2 can only send the data at time slot 2. Okay, so in this way, there will be no collisions between multiple users. All right, so this is about the FDMA, a combined FDMA and TDMA in GSM. All right, okay. Uh, let's go back again one slide. Okay, so this is the architecture of the 2G. This voice, because in the beginning we only know we only it only accommodates voice traffic. Only later on, in the 2.5, when there is GPRS, then actually the same architecture is shown in this slides. But let's focus on this voice network architecture. Okay, so as we have seen in the first slides, basically there are several BTS or base transfer process stations that covers one cell. Okay, one cell, one BTS, and several cells or several BTS are controlled by BSC or base station controller, and then several base station controllers are connected to MSC. Okay, and then there is one gateway MSC to that becomes really like the gateway to the outside networks. Okay, either the public telephone network or the other cellular telco operators. Okay, so we can take the analogy of between the cellular network and the wired networks. So the MSC can we can take this MSC, the analogy of MSC and router. So let's say we can have several routers in the wired networks, but then there is only one gateway router or edge router that connects our network with the outside network. So the same in here. So we have several MSC that connects to several BSC. The BSC can be considered as the switch. Okay, switches. This is just controlling several, like if we are if we just consider this as the Wi-Fi network, we can have several Wi-Fi access points connected to one single single switch, and several switches are connected to router. Okay, and then there are several routers in our networks that defines different network segment. But then to communicate to the outer network, then we only have one gateway router or the gateway MSC. All right, so let's move on to 3G networks. Now we introduce data in our architecture. Okay, so actually, as I said, this architecture is the same as when the GPRS is introduced into the 2G networks, but then there are several differences in the naming or in the terminology that is used, but basically they are the same. Okay, so now the BSC becomes radio network controller or RNC, and of course there are different. It's using different wireless technology, WCDMA and HSPA. Okay, but then the key inside new cellular data network operates in parallel. Okay, so this is now so this is the voice network remains the same as the 2G, and additionally there is data network. Okay, cellular data network, which consists of SGSN and GGSN. Okay, serving GPRS support node and gateway GPRS support node. Okay, so the voice network unchanged in the core, and data networks operates in parallel. Now, if we are looking at the divisions of different part of the architectures, first we have the radio interface. So basically, this radio interface is between the base station and the mobile users. Okay, so as I said before, the early release of 3G is based on WCDMA technology, and later on it's using HSPA. And then the entire radio access networks until this radio network controllers. Okay, or it is called Universal Terrestrial Radio Access Network, or UTRAN. So now from the radio from the RNC and beyond, it is the core networks, part of the core networks. Okay. All right. Now we are at the end of this video. I'm just going to show you, the glance, some glance or basic differences between the 4G and 3G before we are moving on to the more details on the 4G. So first of all, in 4G, it is based on all IP core. Okay, so the IP packets are tunneled from base station to the gateway. So and later on, we'll see that 4G is using a lot of tunneling. Okay, and then secondly, there is no separation between voice and data, unlike in 3G. Okay, so all traffic carried over IP core to the gateway. So basically, when we make a voice call in 4G, so basically it's a voice over IP call. Okay, so it's not anymore, based on the packet switching. Circuit switching as it was done in 2G and 3G. And also, this is the basically this is the data plane. Okay, still the same radio access network, UTRAN, and then the core networks, we're not having anymore. There's RNC. RNC is removed, and then there is no entity that handles the voice traffic. So there is only this one. So basically, this was removed, and we only have this. Okay, this part. But then the naming is different. Now it's just simply called the serving gateway and the packet data network gateway. Okay. Okay, so this is the data plane in the 4G. And on the control plane, there are two more entities called the mobility management entity. This is the one that handles the mobility in 4G. And secondly, there is the HSS, or home subscriber server. In 2G and 3G, this component is called the HLR and VLR, or home location register, and visitor location register. All right, so I think that's it for now. We're going to talk more about the 4G in the next video. Okay, so see you again in the next video then.